Hello everyone, my name is Thidas Fernando. Today I am going to discuss the 2020 A-Level Vectors question. This is question number 14, subpart A of the 2020 A-Level Applied paper. This is how the question reads. Let A and B be two unit vectors. The position vectors of 3 points A, B and C with respect to an origin O are 12A, 18B and 10A plus 3B respectively. Express vector AC and CB in terms of A and B. Deduce that A, B and C are collinear and find the ratio of AC is to CB. It is given that OC equals root 139. Show that AOB equals pi over 3. So, the first thing we are going to do is we are going to draw a rough sketch out of the provided data. So, basically we have the following data. It's given that the position vectors of A, B and C with respect to the origin O are 12A, 18B and 10A plus 3B. So basically, first we are going to write down the data. OA is 12A, so that you get a clear understanding. OB 18B and OC 10A plus 3B. So what we are going to do is we are going to draw a rough diagram out of this given data. So we have three vectors. We have O, we have point O which is the origin. We have C, we have B. So OA is 12A, OB is 18B, OC is 10A plus 3B. Okay. So the first question is express AC and CB in terms of A and B. So we have to first find AC. In order to find AC, we are going to use the triangular law of vector addition. So according to that, we are going to use AO and OC to find AC. So basically, write AO plus OC. AC equals AO plus OC. So this shows that AC equals AO plus OC. So like this, we're going to add AO, this one with AC, AO with OC, so that we get AC is this vector. So here we can see, we know what vector OA is. It's 12A. Now the direction of vector AO is the opposite of that of OA. So it's the opposite to that of OA. So because of that, we can denote it as minus OA. Minus indicating the opposite side of OA, plus OC. Minus OA plus OC. So minus, and we write the value 12A plus OC, which is given 10A plus 3B. So by simplifying this, we can get minus 2A plus 3B. Okay, so we just found vector AC. Next we are going to find vector CB. Again, we can use the triangle law of vector addition to find this. This time using CO plus OB in order to find CO plus OB in order to find CB. CO plus OB will give CB. So that is CO plus OB. So here again OC is given and CO is the opposite of OC. So we write a minus in front and write vector OC plus vector OB. So write minus and express the vector using a bracket here because there are two values, minus 10A and 3B. We have OB, which is 18B. So we simplify the bracket, we get minus 10A minus 3B plus 18B. So if you simplify this, you can get minus 10A plus 15B as the answer. Now we just completed the first part of this question. The first sentence rather. So the next step is to prove that A, B, C are collinear. So basically, in order to show that 3 points are collinear, we have to first show that those two lines are parallel, and those two parallel lines have a common point. So here what we are going to do is we are going to show that AC is parallel to CB, and we are going after you prove that AC is parallel to CB, you can see there's a common point C. So we are writing but C is common, therefore A B, C are collinear. So that's basically what we are going to do. We are going to prove that AC is parallel to CB, right? But C is common, right? Therefore ABC are collinear. So we just found out what AC and CB is. I'm just going to write the two vectors here. Just try to erase it. AC minus 2A. AC equals to minus 2A plus 3B is 1. The other one is CB, which is minus 10A plus 15B. So we are told to deduce that ABC are collinear. So basically, by asking to, the question has hinted us that AC is going to be parallel to CB, by telling us to deduce that ABC are collinear. So basically, what we are going to do is write either AC in terms of CB or CB in terms of AC. Okay? So I'm going to write CB in terms of AC because I find it convenient. CB is going to be something which is in front, minus 2A plus 3B. This is AC. So I'm going to substitute a value here, so I get minus 10A plus 15. So when I put 5 here, I'm going to get minus 10A, 5 times minus 2 minus 10A, and 15B, 5 times 3, 15B. So I'm going to write 5 here. So this is vector AC. CB equals 5AC. So this is basically CB equals delta AC format. Therefore we can write, therefore CB is parallel to AC, but B is common. Therefore, points A, B, and C are collinear. So now we completed the second step also. And what's next? Then you have to find the ratio of AC is to CB. Okay, so when it is this, just found out CB is from AC. So I'm going to use that to find the ratio. So we just found that CB equals 5AC. So first, what I'm going to do is I'm going to find the fraction AC over CB. So I'm going to divide everything AC, we're going to divide it by CB, divide this side again, so I obtain this AC equals C over B. Out of this expression, I obtain the fraction AC over CB. So the AC, the ratio AC weighted to CB is going to be 1:5, and magnitudes are also going to be in the same ratio, 1:5. So yes, we just found it. Next step is to prove that AOB angle is equal to pi over 3. So we have been given that OC equals root 139. Okay. So how do you find AOB? First, let's see why the data is given. Data is given. We try to straight away find AOB. You can find it by multiplying OA and OB. So if you multiply OA and OB, we are going to get an expression in terms of cos theta, where AOB is theta, where this angle is theta. We are going to get an expression in terms of that. So the is modulus OA times modulus OB times cos theta. Here theta equals AOB. So we are going to get something like this. I'm going to let theta equals AOB. So OA is 12A times 18B equals modulus OA, which is 12, and modulus of A is going to be 1 because it's a unit vector. Again, multiply this by 18, and the modulus of B is also again going to be 1, and times cos theta. Then I can write this as 12 times 18. We'll write it as 12 times 18 so that it's in a more convenient format. 12 times 18 times cos theta. So I'm going to divide the left hand side and the right hand side by 12 times 18. So now I get A times B equals cos theta. So here in this particular scenario, we have two unknowns. We don't know what A times B is, and we don't know what theta is. So what are we going to do? to solve this problem, it is given that OC is root 139, which means the modulus of the vector OC is root 139. So that's the hint. We are going to solve. We are going to find A times B out of OC. So I am going to erase this so that I have more space to write. Basically, we are going to find A times B in terms A times B using OC. So we have OC, which is equal to 139. So OC is a length which is basically the modulus of vector OC is equal again 139. So in vectors we learn a theory that the square of a modulus of a vector is equal to the square of a vector. So according to that, if we square this, we square modulus OC, modulus of vector OC, we are going to get 139. Since it's also equal to the square of vector OC, then write it in that way. So again, now I'm going to substitute the values of OC, write it down. So I get 10A plus 3B squared is equal to 139. So I'm going to simplify this expression just like any other algebraic expression. So I get 10 squared, this term squared, A squared is 2 times 10 times 3, which is 60 A times B plus 3 squared B squared equals 139. So I just expanded this. So as you know, as the question has provided that A and B are unit vectors, we can remind ourselves the theory that the square of a unit vector is 1. So I can write this as 10 squared times 1 plus 60A times B plus 3 squared times 1 equals 139. So I'm just going to erase the 1 because it's clearer to have this expression. So I'm going to simplify 100 plus 60 A times B is equal to 3 squared, which is 9, which is equal to 139. So 100 plus 9 is 109. 60 A times B plus 109 equals 139. By solving this, we can obtain that 60 times A times B is 30. So therefore A times B is 30 over 60, which is half. So we just obtain the value for A times B. Now easily we can find the value of theta. So I'm just running out of space. Write it here. Find it. We found that A times B equals half. So I'm going to erase all of this. Hold on. We are going to finish the question. There's just a bit to go. So we just have to put the finishing touches to this question. Almost over. Yes. So as we found out before, found out that A times B equals cos theta. So basically now we found out that A times B equals half. In the previous sub question we found that A times B equals half. By solving OC we found that A times B equals half. So then we calculate cos theta, because these two are equal, can write that cos theta equals half. So therefore theta is going to be equal to cos inverse half. And we know, if you are familiar with the trig table, you can easily find out the value. Cos inverse half is equal to pi over 3. Previously we defined theta as we wrote let theta equals A over B. Therefore A over B is equal to pi over 3. And yeah, that's the end of the video. We just discussed the 40A subpart of the 2020 A-level applied paper. Hope you learned something from this video, and thank you for watching.